Hey coders, and welcome to episode 4 of our Python technical interview course. In today's episode, we're going to be taking a closer look at operators. So operators in Python perform actions on one or more values based on their data type. And you've probably already encountered operators before, right? For instance, the plus symbol or the minus symbol, the division symbol. Maybe the and keyword for comparison, the or keyword, the greater than symbol, the less than symbol. All of these are operators. So I want to highlight the latter part of this phrase based on their data type. And that is because operators actually can produce different results and have different behavior based on the data type of the values that you're trying to operate on. So let's take a look at the right-hand side of the screen. Let's say that we were trying to use the plus operator to add two numbers together. So if we were to say 7 plus 7, that would evaluate to, as we would expect, 14. However, if we were to say the string 7 plus the string 7, that actually might produce some unexpected results. That would actually produce the string 7, 7. And that is because when used against strings, the plus operator actually does something called string concatenation and smushes the two strings together. So we also have the double equal sign operator, and that will check for equality. But likewise, this also is dependent on the data type. So we know that the integer 19 definitely equals the integer 19. However, if we were to compare the integer 19 with the string 19, that's actually going to evaluate to false because, again, those two values are different data types. Now, so far we've been looking at operators that are just a symbol. However, Python has operators that are letters as well. For instance, the in operator will check for membership. So if we want to see whether the letter R was in red, all we need to do is type out what's on the screen, and that is R in red, and that will evaluate to true. Let's say that I were to give you this expression. This is a long and complicated expression. How would you say that Python is going to go about evaluating this? Will it go from left to right? Will it go from right to left? Actually, Python has something called the operator precedence, and that is it will actually evaluate operators before other operators, right? Certain operators have precedence over other operators. Now, I'm not going to go over the entire list. There's a lot of great resources online that will show you the actual precedence of all of the operators in Python. However, just know this is a pro tip. If you're ever in a crunch and you don't know whether a certain operator will, evaluate before another operator, and say you're in a high stress environment such as an interview room, you can always wrap certain expressions in parentheses because parentheses are always going to be evaluated first. So that's just a pro tip. Again, if you forget, say, the operator precedence order, and you want to just be very explicit, just wrap whatever you want evaluated first in parentheses. All right, let's take a quick look at some practical examples in the code demo. Operators in Python can be classified into one of 7 different groups. They can either be arithmetic, comparison, assignment, logical, bitwise, membership, or identity operators. Now, Python provides so many different operators, and there's so many different ways that you can actually use them with different data types, so we won't be able to provide an example of every single use case. However, I did want to touch on some of the most frequently used ways of, again, using these operators. So just as a side note, operators, again, have precedence. You don't need to memorize the exact precedence of everything, but it is really good to know that parentheses will always be evaluated first. And it is nice to know as well that the or keyword will be evaluated last. All right, so let's start off with these arithmetic operators. Very straightforward, exactly kind of how you would expect. For instance, if you wanted to add two numbers, you would just use the plus operator. But this plus operator also comes in handy with different data types. For instance, with two lists, if you're trying to add together two lists, what that will do is it'll combine the values of those two lists to produce a new list. Similarly, with two strings, it's going to concatenate those two strings to produce a new string. We also have the minus sign, the multiply sign, and again, this multiply sign will multiply two numbers to get the product, but you can also use this with a list, say. If you wanted to multiply, say, the value of 2 in a list by 3, what that's going to do is it's going to copy that value 3 times and then put that in a new list. Similarly with strings again, if you wanted to repeat this string 2 times, you could use this asterisk, and now we have this new string David David because we repeated that string twice. We also have the division symbol. That's pretty straightforward. This symbol right here is pretty unique to Python. It's floor division. So now if I were to say divide 5 by 2, I would get the result 2.5. But if I did 5 floor division by 2, that's going to divide these two numbers and then round down to the nearest, round down to the closest integer. So if we were to, again, 5 divided by 2, get the result of that, that would be equal to 2.5. And now we're going to round down to the nearest integer, and that is 2. This percent sign is the modulo sign. So what that's going to do is it's going to get the remainder. It's going to return the remainder of this division. So 5 divided by 2, again, is 2.5, or another way of saying that is 2 with a remainder of 1. And so this will return for us that remainder, which is 1. This double asterisk right here is the exponent operator. So what this is going to do is going to take 5 to the power of 3, and 5 times 5 times 5, as we all know, is 125. All right, let's move on to comparison. So comparison, very straightforward. This double equal sign is going to be checking for equality. So 2 plus 3 definitely equals 3 plus 2. This bang plus a equal sign is basically not equal to. So 2 plus 3 definitely does not equal to 6. That is also true. We also have greater than or equal to, less than, and also less than or equal to. All right, let's move on to assignment. So there is the assignment operator that we all know, which is the single equal sign. That's going to assign a value to a variable. However, we have these additional assignment operators, which is basically shorthand for doing these operations. So let's say that we wanted to do data plus equals 22. Basically, that's shorthand for just saying data equals data plus 22. So it's going to take the value of data, add 22 to it, and then reassign the variable data to that result. Just like that. And that's how it works for all of these operators right here. So even for exponents, it's going to say, data to the third power and then reassign that to the variable data. All right, now let's look at logical operators. These are and, or not. In other programming languages, you might see it like this for and, for like this for or. However, in Python, we can actually explicitly spell it out. So 5 greater than 3 and are in red. Both of those statements are true, so that's going to be true. 5 greater than 30 is false. However, R in red is true, so this or, logical or, is going to return true for the entire statement. And then not will basically negate whatever statement we have. So 50 equals 50 is true, but since we're going to be putting that not operator in front of it, that's going to flip the result and now return false. All right, next we have bitwise operators. These, I don't really honestly see these a lot in interview questions, and quite honestly, I think they're pretty complicated of all of the bunch. So we won't spend too much time with it. If you have questions on them, feel free to post them in the comments below. But basically what this does is we're going to take in two integers, and then we're going to look at the binary representation of those integers. So 23 in binary looks like this, 37 in binary looks like that. And then we're going to look at each of the bits or each of the place values and then perform a logical comparison on it. So for this ampersand, that's logical and, or bitwise and, I mean. So we're going to say 1 and 1, that equals 1. 1 and 0, because we have the 0, this place is going to be 0. And basically do that for the rest of the numbers. So this is logical and, this is bitwise and, this is bitwise or. We also have a bitwise XOR, which basically is just like it has to be two opposite digits. It has to be 0 and 1. It can't be like 1 and 1. It has to be 0 and 1. This is binary or bitwise not. We also have left shift and right shift. So again, if you have more questions on these, feel free to post them in the comments. But again, I don't really use these a whole lot. But basically what you need to know about this is that we're going to take in some integers and then look at the binary representation of those integers to perform operations on them. All right, we also have membership operators. So we can say like is R in red, and that's going to evaluate to true. And then we can negate that as well. We can say something like is 5 not in this list right here, and 5 definitely is not in this list, so that also is going to evaluate to true. All right, then last but not least, we have identity operators. So we already know that the double equal sign checks for equality, right? But it only checks for equality by value. This is operator is a different type of equality check, and it's checking for equality by object reference. So let me show you this in an example. So let's say we declare a variable x equal to the list 1, 2, 3, y is equal to 1, 2, 3 as well. If we check the values of those two, that's going to return for us true. However, if we check to see if these variables are pointing to the same object in memory, if we say x is y, that's going to evaluate to false, because this variable right now is pointing to a memory reference or a object reference in a completely different spot in memory than this object right here, or this variable, right? These are two different spots in memory. However, if we now assign a new variable called z equal to x, then now z is going to point to the same place that x is pointing to in memory. So they're both pointing to the same place in memory, so they both are pointing to the same object reference. They both have the same object reference, and now x is z. That is going to evaluate to true. So again, I don't really use is a whole lot, and it might be confusing to you, like, okay, what does that mean by object reference? If you have any further questions, again, post them down in the comments. I'd be happy to explain. But most of the time, you're just going to be using this double equal sign to be checking for equality by value. And then the last one again is not, and basically this is just going to negate whatever is evaluates to. So we can say like x is not none. That's definitely true because x is definitely pointing to something in memory that's not just none type. All right, guys, I hope you enjoyed this video and learned a little bit more about operators and feel a little bit more comfortable with them. If you did like it, don't forget to hit that like button and also subscribe for more feature content that are coming out in later episodes. But yeah, I'll see you in the very next episode. We've made it to the end of this video. Let's make sure that we understand operators before moving on to the next one. So question number 1, what's the difference between the single equal sign and double equal sign operators? Question 2, which operator would you use to raise a number to the power of 3? Question 3, true or false? The expression x plus plus adds 1 to x and assigns the result back to x. Question 4, what has higher precedence, and or? Question 5, what is the difference between the double equal sign and is operators?